Welcome to This Explainer. We're jumping straight into a journey of absolute extremes today. We are looking at the frontiers of 2026, all driven by the most massive engine of innovation of our time, artificial intelligence. We're going literally from the microscopic cells editing your DNA all the way out to fuelless sails coasting through deep space.
So what actually happens when AI, genetic engineering, and deep space tech all crash into each other in 2026? It's a huge question, right? The sheer velocity of cross-disciplinary innovation happening right now is just breathtaking. And to really wrap our heads around it, we have to look at both the civilian and defense sides of the equation. Technologies that used to be pure sci-fi are rapidly becoming operational reality, fundamentally changing how we heal, how we work, and how we project power in the most extreme environments imaginable.
All right, part one, the microbiotech and brains. Let's start at the absolute smallest scale, inside the human body.
Look at traditional CAR-T cancer therapy. Honestly, it was a logistical nightmare. You had to extract cells, engineer them in a lab for weeks, and just hope for the best at this immense cost. Well, we're ditching that for in vivo CAR-T. By using mRNA platforms, you get a single infusion that sends instructions straight to your existing T cells. You are literally turning your own body into a self-manufacturing bioreactor. The leap in speed here is staggering, and it actually perfectly mirrors the push for ultimate logistical efficiency we're seeing across major defense and tech sectors right now.
Now, when it comes to tapping into the human brain, we face a pretty wild trade-off. On one hand, you've got non-invasive stuff like EEG caps. Safe? Sure. Portable? Absolutely. But trying to read specific thoughts through the human skull, it's kind of like trying to hear a whisper in a hurricane. On the flip side, invasive intracortical implants give you unbelievable precision, but obviously they come with real surgical risks. The race is currently on to build hybrid bridges that safely and seamlessly decode what's going on in our heads.
And to build those bridges, neuroscience actually borrowed a genius concept straight out of aerospace and defense, the digital twin. So imagine a personalized computational clone of your brain that constantly updates with your real-time neural data. This lets AI predict your cognitive state on the fly. It creates this instant seamless loop between human intent and machine action. It's a total game changer.
Moving on to part two, the human, AI, and robotics. Let's zoom out from the cellular level and see what happens when AI steps out of the computer and into the physical world. Because AI isn't just trapped behind a screen anymore. It's evolving into what we call agentic AI. It's no longer just a tool, it's an independent engine of inquiry. In biomedicine, for instance, Agent AI is out there actively simulating entire clinical trials and hand-picking optimal patients. It's pushing phase 1 drug success rates to a crazy 80 to 90%. It formulates hypotheses, it tests them, and it acts on its own conclusions. And that brings us to this massive number, 73%. That is the chunk of surveyed companies that are right now making concrete plans to deploy embodied AI, specifically humanoid robots. We are not talking about some visionary concept for the next decade. This is a full-scale industrial rollout happening as we speak. Get this, we are tracking nearly 250 known humanoid robot models currently in development. And with target cost dropping to around 55 grand a pop, these machines can take over up to 60% of manual tasks. In commercial manufacturing, and increasingly in military logistics and supply chains, these robots are expected to pay for themselves in less than a year. Also, keep an eye on the global power shift here, because China currently houses 53% of the suppliers in this exploding market.
Okay, part three, the global, energy and 6G. We're scaling up again to look at the infrastructure that powers and connects our entire planet.
6G is right around the corner, and forget about just downloading files faster. The absolute killer feature of 6G is Integrated Sensing and Communication, or ISAC for short. This basically turns the entire cellular network into a massive, omnipresent radar system. Talk about a critical dual-use technology. Civilians will use it to track self-driving cars, sure. But for defense, it means the comms grid itself becomes a real-time sensor to detect, track, and neutralize hostile UAV drone swarms.
Meanwhile, global energy demands are absolutely skyrocketing as we head toward 2040, and renewables alone just aren't going to cut it. But we're standing on the edge of major breakthroughs in fusion energy, and AI is the key unlocking it. Machine learning isn't just managing your local smart grid anymore. Right now, AI is actively optimizing the incredibly volatile plasma cores inside next-generation fusion reactors. It's literally designing new machines directly from predictive physics.
Which brings us to our final section, part 4, the extreme, oceans and space. Let's look at how this advanced tech holds up in the most hostile environments imaginable.
First up, space-based solar power. Imagine harvesting solar energy directly in high Earth orbit. The sun never sets up there. Then, you wirelessly beam that massive amount of power back down to Earth as microwaves. It gives us continuous all-weather power, totally bypassing earthly weather patterns and grounded infrastructure.
Now, heavy industries like mining are going to eat up thousands of terawatt-hours of this space-based power. But the most disruptive application? Definitely defense. The ability to wirelessly beam reliable power directly from orbit to remote, hostile military operating bases is an absolute game-changer. It completely eliminates the massive, deadly logistical vulnerability of dragging liquid fuels across enemy lines. You just beam the power right to the troops.
Pushing even further out into deep space, we're abandoning liquid fuel altogether. Future exploration relies on solar sails, much like NASA's recently successful ACS-3 mission. These craft are literally pushed forward by the physical pressure of sunlight. But to navigate that close to the sun, you need insanely advanced heat-sensitive materials to survive the thermal assault, plus AI systems recalculating trajectories on the fly.
From the vacuum of space, we dive straight into the crushing pressures of the deep ocean. Take a look at the ROV Hercules. After 2 decades of service, it just got a major upgrade with a brand new robotic manipulator arm. Autonomous and remotely operated tech is aggressively expanding what we can physically map and interact with in the darkest, deepest parts of our planet.
And in this really profound intersection of modern autonomous tech and military history, these deep-sea vehicles, along with uncrewed surface drones, were recently deployed out to the Solomon Islands. There, they conducted sweeping, highly efficient archaeological surveys of the World War II shipwrecks from the battles of Guadalcanal. So we're using the bleeding edge of modern defense technology to map and honor the conflicts of the past. It's truly fascinating.
So, as AI accelerates literally everything, from single infusion gene edits to humanoid factory workers, to 6G drone tracking radars, and solar sails soaring between the stars, we really have to step back and ask, from your cells to the stars, which of these 2026 frontiers is going to change your life first? Thank you so much for joining me on this explainer today. Keep questioning, keep learning, and I'll catch you next time.